Thanks very much for getting back so promptly. We're here back on stage. We've got Professor Simon Pearson, Professor Tom Duckett. Sorry, I've mispronounced it 3 different ways already this evening. And I have my magic throwing microphone ball here ready for action. But before we kick off with some questions, I just want to look at the results of the poll. So earlier on we asked you about your current, how you viewed automation currently. The question was, how would you rate the current importance of automated technology and associated software as part of your business? And it looks like, maybe as you might expect from an audience interested in coming to an event about farming technology, that a fairly high proportion of you, 46%, say it's important, you already use it frequently. So is that, when you're talking to farmers about this sort of technology and its adoption, how do you find, what sort of reception do you get? Are they sceptical, are they cynical, or are they sort of quite enthusiastic about adopting the technology?
It depends on the sector. So the sector that's really engaged is the fresh produce sector. So particularly on robotics. So it's all about Brexit, migrant labour, availability of people. And that's not just, and that's a worldwide thing. So when we travel around the world, it's always about the biggest number one is fresh produce. And although in the UK we've got Brexit, in America you've got Donald Trump and Mexican Labour. In Japan you've got ageing farmers, no net inward migration. In China you've got a very ageing demographic. So around very high labour use areas with lots and lots of people picking fresh produce, it's a very, very high level of engagement. I think in arable area it's coming. So, I think there's huge interest. I think people know that they've got to drive productivity. They've got to be more efficient, and I think there's a lot of people who are very interested in technologies as enabling technologies. So arable's a little bit behind, I think, in terms of the farmer's mentality, but it's coming. And I think with the rate of change of technology, particularly when we start to integrate all these devices, then it's really going to happen. So we're not quite there yet, but you can see it quite quickly.
Tom, do you want to add anything?
I've really not got a lot to add to that. So usually I'd speak to people who are very interested already, but that's because Simon and his team have done a good job in getting us to speak to the people that are interested in the first place. I mean, from my experience, we've had a really positive reception from companies that we work with. So some of the agricultural machinery makers, so people like Garford Farm Machinery, House and Sprayers that we work with on projects, we found that they're very positive towards the technology. So yeah, my experiences are positive.
Okay, let's take our first question from the audience, and I'm keeping my fingers crossed that the names I've got here are people who actually are in the audience today. So the first question I'm going to call is from Nick Rainsley. Nick, are you in the audience? Yeah, excellent. Now, how good are you at catching, Nick? Right. Let's try this. Here we go.
How good are you at throwing?
Excellent.
I mean, you've got the question up there anyway on the screen, but with the increasing levels of robotics, networks, cloud-based computer systems, all this sort of stuff on farm, how is that data going to be shared? Because at the moment, networks, 3G, 4G, I mean, I live in rural Norfolk and it's a real scream. How do you see that developing to actually even start to keep pace with what we have now, let alone looking at this technology going forward?
Good question. Is this all going to be stymied by the lack of good connectivity on farm?
Maybe not. I mean, depends. Will we get 5G technology sometime soon? Apparently, then this could be an enabler. Yeah, I don't know.
Yeah, it is an issue, and it will be an issue. The challenge for the technology developers is really to sort of do as much onboard processing of information on the actual machine, and then minimise what's transferred back. So, you know, some of these digital streams, particularly 3D point cloud data, it's huge.
Yep.
And there's just absolutely no way you could transmit that back, even with a very, very high speed broadband system. So it'll be processing high speed on the fly, and then really minimising the data flow back. And that will be a challenge.
Yeah.
Good, but I can see there are technologies like that that minimise the amount of data that needs to be transferred, and maybe can buffer it so that you only have to send it. You can send it when you get the good connectivity, because I know it can vary across fields as well, can't it?
Yeah, and the computer crunch processing power required is also huge, isn't it?
Absolutely. So I think, as you say, there'll be a growing trend towards distributed architectures, where rather than having a central processing unit, you've got computing embedded in the devices, a different machinery on the farm, in the robots. So you can have quite low bandwidth communications. I think there's also a role for aggregating all this data over time, so that when you deploy a robot on a farm, wherever it may be, it can take advantage of all the other robots and all of their experience. So, you know, I wouldn't think that lack of bandwidth is a showstopper. I think there are ways to adapt to this.
Good. I know it's a question that we get a lot on Farmers Weekly. Right, do you want to try and throw it back to me, Nick? Great, thank you so far. This is going to go horribly wrong at some moment, I know. Okay, the next question I want to call is from someone I know is in the audience, because I was speaking to him earlier, Andrew Ward. Some of you might know him on Twitter as Wheat Daddy. You're nice and close, that's good.
Yeah, it's on the screen again, but can robots help us protect a decreasing food production toolbox and assure the public we are producing food while caring for nature and the environment? Because, yeah, science and technology is hugely important, but if we haven't got the tools in that toolbox to produce food, can robots and this sort of automation help us do that? And will it assure the public that what we're trying to do is produce safe food and not poison them?
Absolutely, and I think this kind of electric low power systems that we're talking about, you could potentially have. They could be potentially energy self-sufficient. That all the energy you need, you have solar panels, you have anaerobic digesters on the farm. That we could have a circular economy where where we're not reliant on fossil fuels, where we have systems that are able to work in a more sustainable way. Yeah.
I think a great example of a really positive is robotic weeding, where you're actually using mechanical hoe to kill the weeds instead of chemicals. So I think there's lots of there's lots of really positive environmental benefits, particularly anything that drives productivity. So yield per metre squared, because you've got better information, better control. That's all got to be a very good thing, because your environmental impact per unit of production should drop as your productivity goes up. So lots of benefits. I think the thing we've got to be really careful about is this perception about robots replacing people. That's a concern. My experience, though, talking farming industry, is that where we are with robotics, it's about robots doing jobs that people now don't really want to do, or they're not available. So I don't see a threat from robots in terms of replacing people, because the jobs that we're trying to get these robots to do are pretty low paid, difficult in difficult circumstances, wet, horrible jobs, and monotonous jobs. So it's very important, though, that we've got a responsibility just to keep that message going through to the public. And what we don't want to do is, with robots, have another situation, the GM debate, where the whole debate got a little bit out of control, and then the public went against the technology. That would be poor. So we've all got a responsibility just to keep that in everybody's mind.
I mean, still on the same theme of that, are you having any communication or contact with Friends of the Earth or the Soil Association, looking at promoting or helping and promoting what they're doing, if you like, and what they say we should be doing?
We talk to people like the Environment Agency, Natural England, all those organisations. Not with Friends of the Earth yet. Environment Agency see lots of benefits, because where we're using robots is to do environmental monitoring. So it might be soil moisture monitoring, it might be environmental monitoring. So you can get a much higher quality of data through the application of robotics than you would otherwise. So so far a very positive reception, because those agencies also see it as a key enabling technology. It's collecting the data, then it's humans then decide what they're going to do with the data. But at least you've got a platform to collect the data.
Actually, can I add a question to that? Because I know that one of the things that gets people quite excited about some of these technologies is that they can, in principle, help us to improve or reduce the environmental impact of the way we farm. And one of the ways it could do that is by helping us to be much more precise in the way that we apply some of these inputs. Now, do you think there's scope not only to improve reduce the impact on the environment, but maybe to put together an argument to say some of the inputs that we've lost over the last few years, maybe we could review, because if we can use them more precisely, then the justification for taking them out of our arsenal may no longer be relevant if we no longer are spreading them, into the soil zone, if we can apply them exactly on the leaf where they're needed.
Absolutely, I fully agree. I think the challenge at the moment is we don't have the information to give the level of precision we might want. That will evolve. I think where we underestimate is how complex farming is and crop responses are. So it's such a complicated thing because you've got so many variables. You've got soils, varieties, pesticides, herbicides. The whole thing's interacting in a complex way. Mm-hmm. What we are going to see is I think machine learning to unravel all that complexity. So it's just incomprehensible for a human to understand how crops grow. Period. I'll tell anybody who thinks they know better, then I'd be really surprised. It's incomprehensible. But the great thing about machine learning is, for the first time, I think we might be able to, if we've got enough data, start to unravel some of these complexities, and then that's when precision agriculture is really going to take off, because we can then really start to target things in a proper way, which is considered many more variables than we've done in the past. So, machine learning, and with human in the loop as well, I think is going to be key. Not there yet, but that will come.
Andrew, would you like to pass the ball one place to your left? Because I know that Rhonda, sitting right next to you, also has a question.
I think it'd be safer because Rhonda's ball control skills are probably a bit questionable, so she'll catch that.
I hope she's a good thrower in a moment.
My question's disappeared now. Sorry, my question's disappeared.
It was to do with about helping vegetable producers facing labour issues.
I was particularly interested in the broccoli harvester and the technology that's bringing into the field, bearing in mind lots of our vegetable producers in the country are very twitchy now with Brexit and EU migrant labour. Whether you could see this as being the solution to their problems going forward, and when do you think it's likely to be widely available for them?
Yeah, timing's the key here, isn't it? Is it going to come early enough to help some of the challenges we see in the near future?
We hope so. We can try. We need to have the right partners to work with. We need to work with the right companies that will help us to translate the technologies that we're working on to really work in the field, and that's critical. I think. I think in the academic world we talk about high technology readiness levels. We're doing basic research, and then we need to translate that and make it work in the real world. So, and to do that, we need to work with companies, and we need to work with private sector. We need to work with the right people to help us turn those solutions into real systems. I think this is where, if you look at other areas of automation, I'm actually quite optimistic about agriculture, because if you look at, there's a lot of hype now about autonomous driving and cars and things. But actually, if you think about driving, you're on a road where there are cars passing each other at 60 miles an hour, very close to each other. That's a very difficult environment to be making autonomous decisions in. But whereas if you talk about a tractor in a field, in the middle of a field, driving at 10 miles an hour, I think that's from a technology perspective, that's a low-hanging fruit. That's a much more realistic target to go for. So I really think you'll see these robotic systems in a 5 to 10 year horizon for operations that you're talking about, broccoli harvesting, for example. I think we've got the building blocks. We kind of know roughly how to do it. Now we need to fine tune that and turn it into real systems.
Yeah, I think there'll be some very quick. I think broccoli harvesting will be probably one of the quick wins. The whole world's energised around it. This is, as I say, it's not a UK problem. It's a worldwide thing. And plant breeders as well are also united around it. So what I really hope we see a coming together of all these technologies, genetics, breeding, the whole lot with robotics, and that will be part of the solution. So if I had a cap, if I was going to have a bet, 2-3 years, something like that.
That's pretty optimistic. Fantastic.
On that one. Other ones are much more difficult. So.
Let's see if I can catch from you, Rhonda.
Well, I used to play it 4 years ago.
Very good. Okay, Lee Morris, are you here? Ah, fantastic, nice and close again.
Thank you. My question's it's based around students, but actually it's more about, well, it is about science communication and technology transfer. Your 13 years was a figure you put in, you've just got it down to 3. So currently students that have started already, in terms of future-proofing for the sector, I'm sure students at Lincoln University are all over this, and your undergrads, right. But there's 68 land-based campuses around the UK with agricultural students in many of them. So my question is, how do we get the technology transfer to catch up? Because the speed of technology development now, I would say, is so quick that it's always been a challenge, but it's even more important now because those people are on programme. So is there a way that we can do technology transfer and science communication better to everyone, let alone those already in the industry?
Well, one thing to say on that, I mean, I read a statistic recently that 65% of today's students will work in jobs that don't even exist yet. So I think the key to this is flexibility, that in institutions like universities, colleges, we can't necessarily train people on exactly the systems that they'll be using in 5 years' time or 10 years' time, but we need to give them the toolkit, the skills to be able to adapt and to new systems. So in my field, computer science, we don't train people to program in a specific language for a specific system. We train them to be generalists and to be able to adapt to learn any system. So I think that's part of the key. Yeah.
It's a genuine concerning issue, and it's I don't have a solution to that. It's just that everybody's got a responsibility to help with that. So we recognise that fully.
I mean, in every college, I would say there are staff working who would want to do that.
Yeah.
And it's a case of how can they all do it better, I think.
Yeah.
Or work maybe with and link into what you're doing to cascade it.
Yeah, and hopefully it's using technology itself to help cascade that. I mean, this is being streamed out on the internet. So if we can use those sorts of resources, that's a wonderful thing. But there's always more that we need to do.
In terms of innovations, I mean, we're talking today about automation, and we're basically looking at existing agricultural systems and saying, how can we do them with computers, how can we do them with robots? Then I think you get to a certain point, and then you start to see possibilities to re-engineer the systems and do them in completely different ways. Seen in warehousing, Amazon bought up a company called Kiva Systems that completely changed the way that warehousing operations work in companies like Amazon. It used to be that you had human pickers and they would go around, walk around a warehouse to certain bays and pick the stuff. Now they've turned all of the humans are stationary, and they've turned the picking bays into robots, and the robots come to the people, and they massively increase the productivity by doing that. But that's a completely new system, and so I think you get to a certain point with automation, but then maybe there are completely different ways to re-engineer these systems and do things in a completely different way. So I think it's the students now will be the ones that will perhaps be able to come up with completely new ways of doing things and change the systems for the better.
So instead of fitting the robots to the way we farm, we might adapt the way we farm to suit them to be more appropriate for using robots.
I think that will happen.
Yeah. Do you think it's fair to say that, as we've seen over previous decades, that the future perspective is for the number of people on farms to continue to reduce, but the skill levels that are required of those people to go up because of this increasing use of technology?
Yeah, very, very much so. I mean, I see I mean, Tom and I discussed this quite a bit, but if you take machine learning, for example, and trainability, you've got to have a person who's training these robots. If you think of a modern tractor driver, they're not actually doing a huge amount. CTF controlled tractors or GPS steering systems. So you've got a human resource on the tractor who could actually be spending time doing the machine learning for the robot. So that's a very high skilled, upskilled job. But I've got no doubt the modern tractor driver is going to be very, very different, and he'll be training robots. He'll be doing machine learning as part of his job. That will be a higher skill level. The challenge for product developers is just making that trainability as easy as possible, so that you don't need high-class computer science that anybody can do this. But that will be the future. It will be a person who will be training, be machine learning.
Might have to stop reading Farmers Weekly in the cab. Close one. Great. That's doing okay so far. I know. Keith Norman, you're here, aren't you? Where are you, Keith? There we are. A bit further away. Okay, here we go. You ready? Hooray.
If you look at sort of the recent past of a lot of the development of this kind of technology, it was really dogged with a lack of compatibility, and they were having systems, whether it be in-cab controllers not talking to machines behind the tractor, sensors not talking, file formats not compatible, upgrades that would knock out systems. And it really was putting a bit of a brake on the development of this technology. Has that now changed, that you're aware of, that people are actually working more together in a more sort of harmonious kind of culture and background? Because I think a lot of it was initially that, you know, manufacturers wanted to promote and create a system that only their system would work with and exclude all the others. But, you know, in this world where we want to really progress this technology, we need a compatible system that is you know, works for everybody. And are you detecting more synergy between the various players? And instead of everybody working in silos, that everybody is sharing ideas and experiences. And really the other part of my question is the new Agri-Tech Centre, the Agri-Epi Centre that's based up at Harper, could that be an industry coordinator that's going to sort of act as a soundboard and a coordinator for all of these different silos that are going on all over the place with people working individually?
Well, I mean, I can comment from my field in robotics. This is something that's happened in the past 10, 20 years. That when I was doing my PhD studies 20 years ago, everybody developed their own systems. Every university had its own software libraries. Everybody did their own thing. Everyone was completely siloed. And then just over 10 years ago, there was an effort by the whole robotics community to create an interoperable kind of architecture, software architecture, which was called ROS, Robot Operating System. It's actually not an operating system, but it's a middleware. But basically, we came up with a way that we could share what we do. So rather than spending, if you're a research student, spending 80% of the time developing the infrastructure you need to do your actual research, you could use these toolkits which are already there. And we can see this now going out into industry. There's an industrial version of this software, and I think that's a trend. That's also a trend that we see as part of this so-called fourth industrial revolution towards interoperability. You need to have standards, so at some point the big companies have to get together and agree on the standards, or you know, whatever mechanism there is. But I think you're absolutely right. You need to have that. You need to have that common architecture, plug and play, if you like. I think that's key to these technology developments that we're talking about, the being able to share data and so on across the industry.
So do you think we have to bang some heads together to make that happen, or are the manufacturers already starting to do this?
I think there's a great danger that people will, other technology developers will disrupt around them. Yeah. So I think if they don't create interoperable systems, somebody is going to develop an interoperable system which can be retrofitted, and I think that's what's going to happen, unless they really do start to bring this together. The whole of you can't realise the potential of agriculture until you can make all these devices interoperable. It's a real barrier. The world won't wait for that. The world will disrupt around it if that interoperability is not given. So my message is heads do need to be banged together. If they're not banged together, the world will just move on. Look at IBM and Bill Gates. It's a great example. They tried to do the hardware, forgot about the software. Where's IBM? Where's Bill Gates? So these things move very quick.
I know that there actually are some initiatives in the background that are pulling some of these big manufacturers together to try and get them to agree standards, because there is a tension though between their desire to get a competitive edge and have an advantage over their competitors, and the understanding that you guys won't adopt this stuff if they're all different competing technologies and it doesn't work together. Everyone's going to lose out. But I know there are discussions taking place, and pretty much the same question I know was asked by Chris White as well. So thanks, Chris, for that. Graham, you've attended all of these sessions. Graham Potter, should we see if we can do a person-to-person throw this time, and I don't have to get involved? And I'm interested to hear exactly what your question is. It's about the law and how that relates to these developments.
Yeah, I mean, I'll just briefly talk a little bit about our farm so you can get a bit of an idea. We have 500-acre arable farm producing mainly cereals. The only time we steer a tractor is down the road. When it goes into the field, we don't touch the steering wheel. So basically our tractors and everything run as robots as they are, apart from I sit there and go, okay. We also use drone technology using drones. And at the moment, like Amazon, they're wanting to deliver parcels. What I would like my drone to do is be able to fly out on a Monday morning or a Wednesday morning or whatever morning, go and fly the farm, and then the following day have a load of data sat there for me, so I can then go spraying to go and spray those areas, which I'm doing already. But at the moment, the law is kind of holding us back on some of these things, especially with the flying drones. That we can't just let them fly off and do what they want to do. Yeah. And I suppose it's a little bit the same with tractors, is it? You can't really set a tractor off, it goes out the yard at the moment, can we? Go to the field and do its thing and then come home. I mean, I'd like to do that, because at the moment, all I'm doing is going, okay. That's all I do. Yeah. As a tractor goes in the field, it turns around, it lifts the kit up, it does everything it has to, and I just go, okay, every time. I'm like a train driver that's just pressing a button, making sure I'm staying awake. Yeah. Whilst I'm watching a film on my iPad, you know.
Well, you'll be machine
but
learning.
that's what it is.
you'll be doing lots of training, I think. My own take on this is autonomous cars. There's no doubt. I think there was on the news this last week that there's going to be an autonomous vehicle driving from Oxford to London in a couple of years' time. I don't know exactly when. Yeah. But if the HSE are allowing that sort of a level of autonomy in a public environment, it'll come into farm environment. So it's not there yet, but agriculture, I think, will follow autonomous cars. So it'll come. I don't know about drones. It's not my area of expertise, but I think there are other problems around aviation safety that's not my area of expertise. But on autonomous vehicles, I think it'll be.
I think that's a really good example, because I think we'll tolerate a higher degree of error from a human than we will from a machine. So we have car crashes all the time. People die in road accidents. There's usually a human behind the wheel, but the moment it's an autonomous system, then it becomes a different thing. So I think it'll take time for people's perception of this to change and the legal frameworks and things to change. But ultimately, if an autonomous system can be safer than a human, then that should be a good thing. But I think there's definitely a role for the human in the loop as well. Maybe not just pressing buttons, but I think there'll still be a role for the human in all of this.
Definitely a role, down the line for the, because you still need a human eye if something goes wrong. I think. I mean, if you send a machine out there and something goes wrong, it breaks down. There's nothing better than the human eye to say that a robot can't always tell when something has actually gone wrong. If a stone's jammed in or something, So you definitely need that human eye thing. I mean, I'd love to see a dozen robots on my farm whiz out every day and go and do the work for me. It'd be fantastic. And I know we'll get to that one day, and I'm looking forward to it. And hopefully I'll be the first to do it. Because I always like to see myself the first on all new technologies. And I've actually done a few firsts in the world on our farm. We were the first to do variable depth subsoiling. The first, I invented a dryer app for my dryer to control my dryer from my phone. We did that about 6 years ago. It's about 6 years ago now. Nobody else had done that. And just all these little ideas. And I always have new little ideas in my head. And the problem is, I haven't got the money to fund these things. So I have all these little ideas what I want to do and things I want to do, but I can't do anything about them.
sounds like you guys should be
We're
talking a
chat.
bit more closely. I think you've got a volunteer here
Yeah.
to try out some of your new exciting kit on his farm. Make a note.
Absolutely.
Thank you.
We're getting tight on time, so I think we can have one more question from the floor. I've got one from Phil Edwards. Phil, are you here? Ah, Graham, can you hurl it over to Phil? Excellent. Close call, but we got there.
I actually asked two questions, but the one that I'm particularly interested in is you have champions of technology who are investing in land, and I mentioned out there Mr. Dyson being one of those. He's been a champion of technology in the past, and now is heavily invested to land. Is there any way that you use champions like that, not only for UK agriculture and for UK development, but also to help you in your causes?
They're keen on technology and they've got deep pockets. Are we tapping them?
Well, I think that's one great example. You know, that what's really pleased me and surprised me is the interest of lots of technology companies, not just Dyson, but defence companies, high-tech companies, photonics companies, IT companies, big data. I can tell you there's a huge interest in agriculture. And I think one of the great things about the ag tech catalyst and that system is it's created a huge amount of awareness in general industry about the opportunity within agriculture. And so I've got no doubt that's been a really positive thing, and that will stimulate our industry for many years to come. So there are lots of people who want to step in, and my phone is always going with new companies who see opportunity in agriculture. So,
I mean, related to that, there was some time ago the Mars project, was it, monitoring agriculture by remote sensing, and they were trying to predict yield effectively so that you could, to some extent, perhaps rig the stock market and see what the future's developments would be. Has that continued in any way, or has that come to an end now?
no, I see it increasing. The classic example of that is the crop insurance market. Who knows what the Brexit's going to bring, but if you go to France, they have a crop insurance market where that market is underpinned by remote sensing forecasting yield. So within the UK, I see that as going to be an enabling technology. It's still globally important in key commodity crops, cocoa, coffee, tea, all forecasted by remote sensing. So we're not seeing a huge impact in the UK, but if we have a technology-enabled British agriculture policy, we're going to see that. That will be an element of it, I'm sure.
Okay, I know there are still more questions that are out there, but we have to draw it to a close because we've got another part, the final part to this evening's session. So two things. Firstly, I'd just like to really thank our two speakers in the main part of the session tonight, Professor Tom Duckett,
Yes.
hooray, and Professor Simon Pearson. So can you give a big round of applause to our two speakers? I hope you've been enthused and excited by some of the technology they're talking about. I certainly have. James, we've got another poll we were going to ask, haven't we? Because as our final speaker prepares, I thought we could put that final poll up. If you can sort of put that on the screen, and I will introduce, or do we have it up there already? Ah, that's it. So think about what would benefit you the most. So the question on the screen is, what would be the most beneficial development in robotics, automated technologies and associated software for you and your business? So if you can give that thought, whether you're in the audience or watching on the internet from home, and while you're doing that, I'll introduce our final speaker for the evening. So we've heard a lot about the technology that's going to come down the line in the future. To finish the evening, we wanted to bring it down to what's happening on the ground today. And I'm very pleased to introduce Jamie Marshall-Roberts, a new farming technology lead from Syngenta, our sponsor for this whole series of lectures. Jamie is leading a team that's investigating and developing new technologies across a number of areas, including applications, drones, weather data, and image analysis. And he's going to look at some of the areas that Syngenta is working on now in robotics and automation technology. So, vote on the poll and give a round of applause to Jamie Marshall-Roberts.